Hello students, welcome to the lecture of Basic Concepts of Chemistry. In the last lecture, we had discussed about the law of multiple proportions and we had discussed some examples. Today we will do some numericals and examples based on this law, and then we will move on to Gay-Lussac's law of gaseous volumes. So let's see what the law of multiple proportions was, and let's discuss further into it. So, the law of multiple proportions stated that if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in simple whole number ratios. So, we had discussed certain examples. Let's say hydrogen and oxygen combine to form two compounds, one is water and another is hydrogen peroxide. So, in these two reactions, the mass of hydrogen was fixed. Okay. Let's say if we calculate the number of in the terms of molecules, then one molecule of hydrogen was reacting with different molecules of oxygen to form these two different compounds. And if we talk about mass, we will see that the ratio of hydrogen was 1, while the ratio in terms of oxygen was changing. For water, it was 1:8, and for hydrogen peroxide, it was 1:16. So, we had seen that the ratio of the masses of oxygen in these two reactions were in the whole number ratio of 1:2. Now, we had seen some other examples also, like sulfur and oxygen form SO2 and SO3, where the ratio was 2:3 for oxygen. Similarly, for carbon and oxygen, we have carbon monoxide and carbon dioxide. They also followed this law. And for nitrogen, we had discussed about various oxides which were all in a simple whole number ratio in the term of oxygen, whereas the mass of nitrogen was fixed in all of this case. That is, in all of them it was N2, that is 14 into 2, that is 28, whereas the masses of oxygen in each case was changing. So, this was the law of multiple proportions. Now, let's discuss some examples based on it. So, the first example is two different compounds are formed from nitrogen and oxygen. The first compound contains 14.0 grams of nitrogen and 32.0 grams of oxygen. The second compound contains 14.0 grams of nitrogen and 48.0 grams of oxygen. Show that these data are consistent with the law of multiple proportions. So in this problem, there are two compounds, okay? So compound 1 and compound 2. So we have compound 1 and compound 2. So what the information is given? The information says in the first compound, the mass of nitrogen present was 14.0 grams. So let's say we have nitrogen and oxygen in both the compounds, right? Formed by nitrogen and oxygen. So in the first compound, the mass of nitrogen was 14.0 grams and the mass of oxygen was 32.0 grams. Now in the second compound, the mass of nitrogen was again 14.0 grams and the mass of oxygen in this case was 48.0 grams. Okay. Now let's see that the mass of nitrogen is same in both these compounds. That is, in both cases the mass of nitrogen is 14. So the law of multiple proportion says that one atom will be, or one component will be fixed and the other component will change their ratios. Okay. So here the nitrogen is fixed. Now in one case the mass of oxygen is 32 and in another case the mass of oxygen is 48. So we have to find out the ratio of masses of oxygen in both cases. Okay. So M1 was 32 and M2 was 48. So M1 is to M2. This gives us the ratio of the masses of oxygen in compound 1 and compound 2, right? So this will be 32 is to 48. If we divide both of these by 16, it gives 2 is to 3. Okay. So this is a simple whole number ratio. So this proves the law of multiple proportions. Proves the law of multiple proportions. Okay. So let's see one more example. So in this example we have H2O2 and water contains 5.93% and 11.2% of hydrogen respectively. Okay. Show that the data illustrates the law of proportions. Okay. So, now here in this problem, the data is given in terms of percentage and not in terms of mass. But we can always convert this in terms of mass. How? So, first they have given in H2O2, hydrogen is of 5.93%. Okay. So, what will be the percentage of oxygen? Percentage of oxygen will be 100 minus 5.93%, which comes as 94.07%. Now, we can also say that in 100 grams of H2O2, we have 5.93 grams of hydrogen and 94.07 grams of oxygen. Okay. And now in H2O, in water they have said the percentage of hydrogen is 11.2%. So, the percentage of oxygen will be 100 minus 11.2%. So, this comes as 88.8%. Okay. So, we can also say that in 100 grams of H2O, we have 11.2 grams of hydrogen and 88.8 grams of oxygen. Okay. Now, in the previous example, we had the mass of nitrogen constant in both cases, but here this is not the case. Okay. Mass of neither hydrogen nor oxygen is fixed. But according to the formulas, we can see that the number of hydrogen is same in both these molecules, the number of oxygen changes. So, and since the percentage of hydrogen is less in between both of these, let's divide both the percentages with the smallest number. So, let's do like this. This is 5.93 and 94.07. Okay. Now, if we divide both these numbers with 5.93, this comes as 1 and this comes as 15.9. Okay. And in this case, the ratio is 11.2 and 88.8. So, again we will divide with the smallest number and the result comes as 1 is to 7.9. Okay. So, now we have 1 as the common factor. Now, we can find out the ratio between the masses of oxygen, right? So, then the ratio mass of oxygen in 1 to mass of oxygen in 2 is equal to 15.9 is to 7.9. So, this is roughly 16 is to 8, or we can say 2 is to 1. So, this is a simple whole number ratio. So, with this we have completed the law of multiple proportions. Now we will start another law which is known as the Gay-Lussac's law of combining gaseous volumes. Okay, so we will see what is the statement of it. Law of gaseous volumes. This was proposed by Gay-Lussac in 1808. Okay, so the statement of law of gaseous volume says that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume provided all gases are at same temperature and pressure. If the products are gaseous, then they are also formed in simple ratio of volume. Okay, so when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. If the products are gaseous, then they are also formed in simple ratio of volume. Now here the very important factor is same temperature and pressure. We cannot measure, such as we are taking 25 degrees Celsius and 1 atm is one condition, and another condition is 25 degrees Celsius and 2 atm. We cannot measure these two. We cannot use Gay-Lussac's law in these conditions because why? Same temperature and pressure. Similarly, we cannot also correlate this condition with let's say 35 degrees Celsius and 1 atm. This cannot also be done. Okay. So, same temperature and pressure is very important. So, for example, let's say we have hydrogen gas which combines with oxygen gas to form water vapor in the vapor phase. Now, so here the coefficient is 1 for hydrogen, so we can say 1 volume, half for oxygen, we can say half volume, and 1 for water, so we can say 1 volume. Now we can also simplify this reaction as 2H2 plus O2 gives 2H2O. In that case, the volume will be written as 2 volumes of hydrogen plus 1 volume of oxygen forms 2 volumes of water. So, the ratio of the volumes are 2:1:2. So, this is a simple ratio of volume. We will study about the Gay-Lussac's law in further details in the next lecture. Thank you.